Welcome to G Fun Facts Online. Today, we're journeying to the most remote continent on Earth, Antarctica. But we're not staying on the surface. We're going deep, kilometers deep, beneath the colossal ice sheet that covers the land. Down there, in the crushing dark, scientists have just unveiled a secret world, a vast and surprisingly active network of hidden lakes. This isn't just a minor update to our maps. It's a fundamental shift in our understanding of how this frozen continent works and its profound influence on the future of our entire planet. In a landmark study published in the journal Nature Communications, a team from the University of Leeds has announced the discovery of 85 previously unknown active subglacial lakes. This finding brings the total number of these enigmatic water bodies to 231. Imagine, beneath a seemingly dormant slab of ice larger than the United States and Mexico combined, there are hundreds of lakes, many of them actively filling and draining in a complex, continent-wide plumbing system. So how, in one of the most inhospitable places on Earth, did we find them? The secret lies not in drilling, but in looking down from space. The hero of this story is the European Space Agency's CRYOSAT-2 satellite. Launched in 2010, CRYOSAT-2 is equipped with a sophisticated instrument called a radar altimeter. Its job is to send down a radar pulse and precisely measure the time it takes to bounce back, allowing it to calculate the height of the ice sheet's surface with incredible accuracy. The challenge of studying these lakes is immense. They are buried under hundreds, sometimes thousands, of meters of solid ice. Direct observation is a logistical nightmare, but CRYOSAT-2 gives us a revolutionary way to see the invisible. By meticulously analyzing a decade's worth of data, from 2010 to 2020, researchers tracked minute changes in the elevation of the ice. These subtle rises and falls, often just a few inches to a few feet, are the telltale signs of activity in the world below. When a subglacial lake fills with meltwater, the immense weight of the overlying ice, kilometers thick, is actually pushed upward, causing the surface to bulge. Conversely, when a lake drains, the surface above it subsides. It's like watching the slow, deep breathing of a frozen giant. By tracking these movements over a 10-year period, the research team was able to pinpoint the locations of these hidden lakes and, crucially, observe their cycles of filling and draining. Sally Wilson, the lead author of the study, highlighted just how significant this is. Before this research, only 36 complete fill-drain cycles had ever been observed across the entire continent. This single study added another 12 to that tally, providing an unprecedented look at the behavior of this hidden water world. What this new data reveals is a far more dynamic and interconnected subglacial environment than we ever imagined. This isn't just about finding 85 new isolated ponds. The research also identified 5 new interconnected subglacial lake networks. This means the drainage of one lake can trigger the filling of another, sometimes hundreds of kilometers away. It's a continent-wide plumbing system, a network of arteries and reservoirs hidden from sight. This intricate network of lakes and channels plays a critical role. It acts as a lubricant at the base of the ice sheet. Think of it like oil in an engine. This water reduces the friction between the ice and the bedrock it rests on, directly influencing the speed at which glaciers flow towards the ocean. When one of these active lakes drains, it can release a massive pulse of water under the ice. This sudden lubrication can cause the overlying ice stream to surge, accelerating its movement. As Professor Anna Hogg, a co-author of the study, noted, the lake areas themselves can change during different cycles, showing that this subglacial hydrology is much more dynamic than we thought. The location of these lakes is also telling. The vast majority, 73 out of the 85 newly discovered lakes, are located beneath the massive East Antarctic ice sheet, and a staggering 81% of all the active lakes were found under fast-moving ice streams, where ice speeds exceed 50 meters per year. This creates a direct, undeniable link. Where there is active subglacial water, the ice above it is moving faster. This discovery has profound, and frankly, worrying, implications for our warming world and the threat of global sea level rise. The water discharged from these lakes lubricates the base of the ice sheet, speeding up the flow of ice into the ocean. This is where the story gets even more critical. The researchers found that 6 of the newly identified active lakes are located within just 8 kilometers, or 5 miles, of the grounding line. The grounding line is one of the most important concepts in glaciology. It's the point where the ice sheet, which has been resting on bedrock, lifts off and begins to float on the ocean, becoming what we call an ice shelf. These ice shelves act like a cork in a bottle, buttressing the glaciers behind them and slowing their flow into the sea. Having active lakes filling and draining so close to this critical point is like having a leaky, unpredictable faucet right at the foundation of a building. A sudden release of water here could dramatically lubricate the base of the ice just as it meets the ocean, potentially weakening the stability of the ice shelf itself. If an ice shelf collapses, the glaciers behind it are free to accelerate, dumping massive quantities of ice into the ocean and driving up sea levels. And here is perhaps the most important takeaway for all of us. The numerical models that scientists currently use to project the future contribution of the Antarctic ice sheet to sea level rise do not yet fully incorporate the complex realities of this subglacial hydrology. As lead author Sally Wilson points out, these models often treat the base of the ice as much simpler than it really is. This new dataset, providing the precise locations, sizes, and activity timelines of these lakes, is a vital, missing piece of the puzzle. By incorporating this new, more detailed map of Antarctica's hidden plumbing, scientists can build more accurate, more reliable models to predict how the ice sheet will respond to a warming climate. This will help us better understand the ultimate contribution of Antarctica to the rising seas that will affect coastlines all over the world. Now, it's important to note that while many of these lakes are active, not all of Antarctica's subglacial lakes share this characteristic. Many are considered stable, with little change in their water volume over long periods. The most famous example is Lake Vostok. Buried under 4 kilometers of ice, it is one of the largest lakes on the entire planet, estimated to contain enough water to fill the Grand Canyon. Lake Vostok is currently considered a stable, sleeping giant, but the study of these smaller, active lakes provides an invaluable natural laboratory. By observing them fill and drain, we learn about the physics that govern these systems. This knowledge helps us understand the potential consequences if a giant like Vostok were ever to become active. A catastrophic drainage event from Lake Vostok would be a global-level event, destabilizing a huge portion of the East Antarctic ice sheet and causing a significant rise in global sea levels. The discovery of this vast network of lakes also opens up one of the most exciting frontiers in science: the search for life in extreme environments. These lakes have been isolated from the Earth's atmosphere and sunlight for millions of years. The water itself is formed from a combination of geothermal heat rising from the Earth's interior and the immense pressure and friction from the overlying ice. These dark, cold, high-pressure, and nutrient-poor environments are prime candidates for harboring unique forms of microbial life, often called extremophiles. Any organisms living here would have had to evolve to survive in complete darkness, perhaps deriving energy not from the sun, but from chemical reactions with minerals in the bedrock below, a process known as chemosynthesis. The discovery that these lakes are interconnected raises another tantalizing possibility: that life, if it exists, could be transported between these isolated habitats, creating a distributed hidden biosphere beneath the ice. While this study focused on mapping the lakes, each new discovery provides a potential target for future exploration. Drilling missions have successfully sampled other subglacial lakes before, and each new target holds the tantalizing prospect of finding life that has evolved in one of Earth's most alien environments. In the end, The revelation of these 85 new subglacial lakes is a monumental leap forward. It shatters the old image of Antarctica as a static, lifeless block of ice. Instead, it reveals a dynamic, complex system with a secret water network that influences the entire continent and, by extension, the entire planet. This discovery underscores the critical role of continuous satellite monitoring. As Martin Waring of the European Space Agency noted, this research once again demonstrates the importance of missions like Cryosat for understanding our polar regions. The more we learn about the intricate dance of ice, water, and bedrock in Antarctica, the better equipped we will be to predict the future of our planet in a changing climate. This secret network, now partially unveiled, holds vital clues to Antarctica's past, present, and future, with consequences that will be felt across the globe. Thanks for tuning in to G Fun Facts Online.